everybody, and welcome back to the hobby shop. We're still here with the EICO 452 we revived in the last video, and I don't have it synced here. I'm just letting it do its slow walk on its own 60 cycle test. And I just want to throw in a video showing where I tested the triode tubes in this, which I didn't include in the last video because I talked way too much. When I was rewatching it, I absolutely bored myself to death. But anyway, I did check all of the triode section of this scope, all of those tubes, and I promised in the last video to post an addendum showing all of that for those interested. And it could have just been a quiet time in the shop, except for my rambling on and on and on and on the way I do. Anyway, we've got it all back together now, temporarily. I haven't done the final recap on it yet, so it's still running the 200 volt rated capacitors in some of the circuits, which means we're still running on reduced line voltage, less than 100 volts. I'm holding it right now to under 100 volts because that's already driving the B plus up better than 320 volts in it, and that's as far as I dare push it until I've got all the proper volt rated capacitors for this after bringing it along this far. But just got it going on its own 60 cycle test right now. And in the last video I had to replace the vertical gain control, which was opened as a barn door after I soldered on it a little bit. Refer to the previous video on this scope to see all of that. But I've just been marveling at how well the replacement control, this is a used potentiometer I put here to replace the vertical gain control, and how well it's tracking right now with still the original horizontal gain control over here. Both of them setting right at about 20. Horizontal gain, vertical gain just a little touch above 20. But I've also been looking at the horizontal position and the vertical position, how right now these controls are I just set them both pointed straight up. And you see how well that's got it centered here. So all the controls seem to be syncing very well with each other on this scope, a lot better than I would have thought they would have. If we take the horizontal gain and turn it full clockwise, takes it just about off the screen that direction. Full counterclockwise. And then just without even watching the screen really, just point it straight up approximately. And look at how well centered that is. Pretty much the same thing with the vertical gain. The vertical position, horizontal position, vertical position. I get my terminology screwed up, but take it all the way to the top and it just about, well, it does actually disappear. But then take it back down here and it does actually disappear. So just point it straight up. And there we are. It's centered again. So I'm really impressed with that. And operating on the reduced line voltage, I've got it set still to maximum intensity. But we've still got plenty of focus range. It'd have really been cool if it had sharp focus with focus control, just pointed straight up as well. But anyway, all this bodes very well for this scope. by the time it's finally recapped with the caps it's going to have in it from now on. By the time we get where it's up operating on the full 123, 125 volts thereabout, straight from the AC line, this ought to be a very good scope. And on our gain, we've just got all kinds of gain. And that, again, that's operating at less than 100 volts AC right now. Same with the horizontal. And I'll go ahead and sync that for y'all, just to show that it will. There we are. Got good range on the sync control. I'm hoping that I'll get at least a fair amount of use out of this scope by the time it's all finished, and for a lot of the old tube type stuff and everything I work on here, it ought to be adequate for that. But anyway, without further ado, here is the section I deleted from the last video because I just went on and on too long, like I just did right here. But here is the triode test from the EICO 425 oscilloscope project. Hope y'all enjoy if y'all have the stamina. Oh, by the way, a lot of the commentary I'm throwing in there is aimed at total beginners. So anybody who's worked with tube type circuitry and tube type equipment won't get a whole lot out of it. But I'm trying to do this channel, you know, for the total beginners, you know, the total novices at all this. And I talked about some stuff that I really wish some other channels would kind of, you know, not dwell on so much, because I don't really think it's that important. Little shadows in the tops of tubes and everything. Eventually I'll have a video where I go over the way I personally evaluate tubes, and the reason that there's a few instances where you panic, but in a lot of instances you just don't. But anyway, here we go. Trial test for the EICO 425 oscilloscope project. So we got 3 6SN7s, each of them twin triodes, which in older oscilloscopes, older equipment, you could actually, you know, multiply by 2 for each of them and say that the 3 6SN7s are actually 6 tubes. But other than that, we've got 2 6J5 single triodes, which are metal, and this is a pretty simple scope. A lot of people on these channels, I notice, they'll look at these shadow marks above the heaters in the tubes and try to use that as a sign that the tube is high hour or soon to fail. I don't ever worry about that. Y'all, when these tubes were new and when they were tested and just tested at the factory, the new filaments in them would smoke some and cause these little bright spots above them here. So I don't ever worry about that when I see it. The main thing I'm going to worry about with these is, are they, well, I look at the gettering in them, which is looking good in all three of them. You don't ever want to see that discolored, and especially milky. That would mean that one's gone to air. But I mainly, just like with the rectifiers, I'm looking for balanced operation between the two sections, which are identical to each other in these, and no shorts. I don't want it to be dead, and I don't want it to be hard shorted. Mild leakage is unfortunate in cases, but a lot of times that can be lived with. So I'm going to be very careful also to reinsert each of these tubes back into the original sockets that I'm finding them in, because if one shows weakness on a section, or a dead section, or a hard shorted section, that could be a sign of a circuit problem with the particular circuit it was plugged into. But emission wise, I'm just looking for them to be acceptable. So I've got the Jackson 103 now set up for 6SN7, and like with a lot of triodes, the heater voltage you'll see is 6.3 F. So I've got a special test here that I had to set to F for these, but plate will be 35 for each section, and then first test will be on circuit 1 NS, and second test will be on circuit 4 LS on this one, and it's lit up nice and pretty, so we don't see where it's indicating that any short indication would be normal. So I'm going to be paying particular attention to the short indicator as I'm going through this, and we'll see how this one does. Since we've only got 7 tubes total, I think I'll just take y'all along for the whole ride on this, if y'all don't mind. That right there was just a result of the circuit switch being flipped. When I see that, I don't get alarmed by it with this tester, so I'm mainly looking for it to be steadily illuminated, either dimly or brightly. But anyhow, we're ready now for the first test, which will be circuit 1 NS. So I need to set a lockout here. And we're on circuit 1 NS with our plate voltage set at, well, our plate set at 35. Nice and strong. That's the way I like it. Okay, second test will be 4 LS. So I'm going to release that, set the circuit to 4, and L and S. Okay, got a little glitch there. On an old tube tester, that can be a result of just the test buttons being worn. So it's holding steady now. And certainly this old Jackson has every reason to be worn by this point. So that's holding steady on this one. But I'll go back to circuit 1 NS. And yeah, a little flash there. NS. Hit it again. And now it's steady. Okay, let's move on to the next one. We'll just go through and test them in the order we come to them. But no, I don't ever worry about these little spots up in the tops of tubes. I've seen many new tubes right out of the package that show that a little bit. It's just a result of anything new, and when it's first fired up, the original coating on the filament and everything in them, it'll smoke a little bit, and it'll put these little spots up here. Alright, let's go through all of our circuits and one NS. And that's good. On tubes like this, with this tester, you got to know your test equipment. But I would be very, very satisfied if they were just barely into the green with this tester. So the more you know your test equipment, the better off you are. It can only tell you as well as you know what it's trying to tell you. So 4 LS. Not as strong as the other one, but again, very well balanced and not even a mild leakage indication. So if they all continue like this, this ought to be a pretty peppy scope by the time it's finished. Get in there. There you go. Normally on bigger projects, I won't bore people with all of this, but since the results you get and the work you do is based so much on the quality of the equipment you use and your knowledge on how to use it. For a scope as simple as this, we'll just go ahead and I'll bring y'all along for the whole thing. But I promise not to bore y'all later with just endless capacitor testing. Alright, we're locked out on everything. Okay, 1 N S. This thing ought to be very, very excellently balanced from everything I'm seeing so far. Okay, circuit 4. LS. I'm getting better at working through the camera too. Okay, I'm going to call this one excellent as well. All right, come here, honey. Let's see. Try and work through a camera. 6J5. There we are. No special test, so set that to normal. 6.3. Plate on 30. Nice and easy, so I don't have to count these little divisions in here. Notice a little seam here. My knob broke one time on this, so yeah, to get a precise measurement I had to glue it back together. I had another one that fit it, but anyway, original's a whole lot better if you can manage it. Okay, I want to make sure I got my lockout ready. These two ought to go mighty quick. Circuit 2 MS. And I do allow them a little time to warm up. Set my line back a little bit. There we go. And I probably should have done that on the 6SN7s as well, but strong as they were testing, it would not have made any tremendous difference. I was going to be happy with them regardless. All right, circuit 2 MS. Okay. Test every circuit anyway. Again, just some switch action there. Technically, there's no need to go past 8, but I always do. It just feels satisfying to do it that way. Back to 1, and we were testing on 2 MS. Okay. 2. Yeah, always got to be one where my button's missing. Ouch! I call that more than adequately good enough. And rock steady. And if one does have fluctuating emission, normally this tester will show it quite readily, so and the temperature feels normal. And another 6J5. So far, if the CRT tests as good as these tubes are testing, this scope ought to have a lot of life left in it. Decades of life left in it. Okay, here we go. Some tubes, well, some chassis have tubes and pentodes, and you'll have a pentode section and then a triode section, sometimes a diode section, and it takes a lot of resetting. I wouldn't take y'all along for the ride on all the tube testing in one of those, but this one's really pretty super simple. Ow. I gotta get a button for that. I can't find one that'll fit it somehow, actually. I got a box of push buttons, but none that are quite right for this. They're either too tall, well, they just won't let the switch actuate, so I do have to get one of those occasionally using this tester. Come on. Let's make it perfect. A little worn, but very, very good. I'm happy with that. Like I said, on trials, I'm generally, if they're solidly in the green, I'm happy. So we've got a excellently good tube complement in this. Maybe aside from this, which I don't have a way to test, actually, or maybe I do. I haven't actually looked, but I'm assuming I don't. So, we'll move on to the next thing. Okay, that was thoroughly mad-making and monotonous for me to have to listen to again. I don't like editing my videos. I don't like having to watch and re-watch and watch over and over and over again all the clips I use to make my videos. But anyway, I wanted to say something in conclusion. I don't take a tube tester's word as law. Tube testers are nowadays a kind of controversial topic with me and many others out there. You'll get different results from pretty much every single tube tester you use as far as testing tubes in any project. But this Jackson 103 has never been fully refurbished. I've only done what was necessary to it, to ensure its prolonged life and reliability such as it is. It's had no modifications or anything done on it. While I don't take a tube tester's word as law, they are a good indicator if you know the instrument you're working with. This one I calibrated mainly to use on pentodes, and so with triodes and rectifiers. For those who might be saying those tubes are reading mighty high on this. Well, I hope they're actually that good, and it appears to be. The amount of gain we got on reduced line voltage on this, that they are really good, strong tubes. But anyway, I'll have a video coming up sometime where I go over tube testers, and we'll try the same tubes in multiple testers and show the different results they give. I chose this one for this project just because it's one of the easier ones that I have to use, and it's got a good leakage test and short test. It's pretty sensitive when it comes to leakage between elements, registering that, and certainly registering shorts. So that was, as I said, some of the main things I was looking for. Really, with tubes like 6SN7s and 6J5s, depending on the tube tester I'm using, if they're just up there, approaching close to halfway, I'm happy with them. And generally, that is good enough. This one was showing them way on over into the green. But it depends on, what you have your tube tester, that particular one, calibrated for. And like I said, this one I generally use on pentodes. Anyway, just wanted to throw that in as a little additional addendum here at the end of this. But yeah, I've got multiple tube testers. I have to, because I think you can never have too many. Other testers I have don't even have, like these older test sockets and all, like Locktail and the old type based tubes. They don't even have these old sockets on to even plug a tube into, much less test them. So between that and actually having the setup information, which you can't hardly get for any tube tester anymore, or I've never had any luck finding it, drop it in the comments if you know where, for various models and all. Tube test setup information for various models of tube testers can be had. What it all boils down to is I've got multiple tube testers. And for this particular project, I chose this one just because it's one of the ones I kind of enjoy using. And I find its results, accurate to within a degree of about upper 70 to 80%. That's about the comfort level I have, But tube testers don't really, as a rule, give really critical tests anyway. If you really want to critically test tubes, you have to have a schematic for the equipment they're used in and test them operating in circuit, because that's the only real true test you can have of any tube, is how well it is functioning in the circuit that you need that tube to work in. Anyway, though, that's going to do it right now for this edition of Brooks Hobby Shop. Y'all take care out there, and do something you love and never work again. That should be everybody's dream. And just find something to work on and get lost in and enjoy. And we'll see you next time here on Brooks Hobby Shop. We're out.